Okay, welcome to you all to this breakfast session today. I'm Peter Morfee. I'm the Principal Technical Advisor with Energy Safety, which is an operating unit of WorkSafe New Zealand. Today we've got a group of very experienced presenters, each coming to talk to us. We've got Alan Goy, Safety Manager with Fulton Hogan, and he's going to be talking about managing electrical safety and sites and what the good practice and what the not so good practice looks like. Then we've got Andrew Clark, Managing Director from Jim the Builders, and he's going to be talking about the challenges of contractors and subbies. And then we have Evgeny Zakharov from our organisation, from WorkSafe New Zealand, and he's going to explain electrical safety on a construction site and from the workplace WorkSafe perspective. But first of all, let's take a look at what electrical safety is all about. I like this particular picture here. It looks like typical New Zealand practice on a construction site, I would think. Electricity, as we know, provides a convenient and powerful energy source for the construction process. And in some places, such as the Auckland Motorway Tunnel, which you've seen the breakthrough just recently, it's the only energy source that can provide an adequately safe environment. We see our children every day having fun playing on computers, and these are powered from electricity. And generally, most of them are being killed on a regular basis from a car crash or an aircraft disaster or from mortal combat. So our children get to experience electrical safety firsthand in their early days. But after you've had a few of your fingers chopped down a little bit by a circular saw without a guard on it, or your gumboots have been cut open by an angle grinder that decided to start itself up when you plugged it in, or you've had your overalls ripped off by a cement mixer, unguarded pulley, or danced a hornpipe while holding a power drill, you get to know where the real fun of electricity comes from, don't you? The fact that we're here today actually means that we've all been statistically lucky. I think all of you will have had an electrical shock at some stage or other, and statistically it could have killed you. So we're all statistically lucky. Electricity has two unfortunate characteristics. Firstly, in order to power a portable tool, or in fact any electrical equipment, it requires to be able to deliver about 10 times the energy that's actually needed, and gives it the ability to create havoc in a significant way. But secondly, our bodies rely on electricity to control our muscles, and more unfortunately, the way our hearts work requires that muscle not to be receiving electrical signal during a depolarization time, such that if you get an electrical shock at exactly that moment, the likelihood is that you will die from that shock. And that actually applies even when you're using an RCD. An AED is useful if there are people around that know how to use it. One advantage that we do have, though, is in most cases, if we come into contact with electricity, our muscles will actually react and break the current before the time that it's present for is sufficient to kill us. Electrical cables and switchgear in our equipment is designed to provide two levels of protection: double insulation, earth construction and the like, and it's these layers of control that actually save our lives from day to day. When electrical shock occurs in the normal dry circumstances with insulated floor coverings and footwear, the experience generally only needs the attention of a good hairdresser. In this environment, the electrical current that causes both the burns and electric shock is limited by the insulation of the clothing and the flooring materials. However, where the circumstances provide an environment that conducts electricity through wetness or conductive items such as scaffolding, the current is only limited by the resistance of our body, and that's not enough to prevent a fatal electric shock. We would need serious medical attention to be able to survive. So enter RCDs, isolating transformers, and very low supply voltages. These devices reduce the time or the current that can flow in the event of an electrical shock. And if they're in good condition, they offer excellent, but not entirely fallible protection. These devices, supply systems, reduce the time and current that can flow and therefore protect us. The key with electrical safety, therefore, is not to tempt it to decide to take you out. One of the things that's interesting in the morning, if you back your van out onto the street and only the handbrake manages to stop it, we don't check our warrant of fitness and decide, well, it's still valid, so it's safe to drive on the motorway to work. The same applies to electrical equipment. If things aren't working correctly, then it is a warning that things could go wrong. If you adopt a practice of checking the equipment each day before installing it, and you put your cables well out of harm's way, then you won't tempt electricity to test your resistance to it. Electricity is like a wild lion. It doesn't waste its time chasing those who respect it and heed the warnings. It lies in wait for the unwary, those who take unnecessary risks, and then it strikes with intensity and commitment. Never trust a sleeping lion. So when you wake from your dreams in the morning, remember that there are some jobs you should not do, and there is some equipment you should not use. So welcome to the session then, gentlemen, ladies, on electrical safety. Our first speaker this morning, as I said, is Alan Goy from Fulton Hogan. So if you could welcome him, I'll pass over to him. Thank you.